Another question of Hcv plus HOTS series. Two small spheres, means ball, each having mass 20 gram, are suspended from a common point by two insulating string of length 40 centimeter each. The spheres are identically charged and separation between the spheres or the ball at equilibrium is found to be 4 centimeter. Find the charge on each sphere. The diagram is like that. Two spheres, this one is this, suspended from the common point. Here it is 40, here also 40 centimeter, and it is observed that this particular distance is 4 centimeter. Then these two are at equilibrium. So you have to find out the charge on these. These two are having the same charge. Say the Q charge and Q charge. So here the mass is there of this particular ball or sphere. So 1/4 is your mg downward. Here also mg. And here the tension is there, so definitely it is going to resolve into two components. One is your T cos theta. Here this is a theta. Here also T cos theta. So considering only one place, and here the T cos theta, another component is your T sin theta. That is your horizontal component. So what we are going to observe, the T cos theta is balancing mg. So the T cos theta is equal to m into g. And this T sin theta is balancing the repulsive force between these two. Same charges, 1/4 is acting in this way, So we can write a T sin theta is equal to electrostatic force of repulsion between these two. So if we are going to divide these two, then what happens? Fe by mg, this by this is equal to, you will get a tan theta, right? So Fe is equal to m into g into tan theta, and Fe, same charges, q square pi 4 pi epsilon naught into 4 centimeter, that is 0.04 whole square, is equal to, mass is given of the each sphere is your 20 gram, 20 by 1000 into g 9.8 into tan theta. How will you find out the tan theta? Tan theta, if we are going to draw this particular then it will be theta, and then theta is equal to, and you have to find out the, so by finding the tan theta, p by b, this by this, you can easily find out the answer. You will get that Q is equal to 4.1 into 10 to the power minus 8 coulomb. You can easily find out the Q. The tan theta is equal to P by B. You can find out the value. That will be your answer. Another interesting question. A rod of length L has a total charge Q distributed uniformly along its length. It is bent in the shape of semicircle. Find the magnitude of the electric field at the center of curvature of semicircle. So the diagram is like that. Semicircle is there. Semicircular. This is the center. This is a rod. Is having charge Q. So let us consider a small piece of rod and that rod is making some angle from the center of curvature. Say this is theta, and this is your from the vertical, and this is your d theta. Radius is r, so definitely this length will be r d theta, right? So our purpose is to find the magnitude of the electric field intensity at the center, ये यहाँ पर, due to this charge rod, right? So definitely, what should be the charge on this small one? dq is equal to, what should be the charge? q by l r d theta. How it comes? We know if the length is L, we are assuming this, however the pi r length is there, if the length is L, when L is the length, charge is q. When r d theta is the length, the charge will be q r d theta by L. That is your dq, right? And then we know in this particular case only the vertical component plays an important role. Here the vertical component of the electric field intensity is along this, that is the E cos theta, and horizontal component are going to be counteract. यहाँ पर एक पॉइंट लिए हैं तो यहाँ पर इधर हो गया कॉस कंपोनेंट, साइन कंपोनेंट, फिर इधर पॉइंट लेंगे तो इस तरफ साइन कंपोनेंट हो तो हो गया, इसलिए ये दोनों कैंसिल हो जाएगा. ओनली वर्टिकल कंपोनेंट will be there. Only vertical component will be there. No horizontal component. Only vertical component. So vertical is your cos theta. So we can write it. The net electric field intensity is equal to integration of dE cos theta. That you can write the d, small pieces is there, small piece, so dE cos theta. So dE cos theta, we know intensity E is equal to k q by r square, that is your k q by r square. So directly I can write it, k, q is how much? Q is your q by l r d theta, right? This q by r square into cos theta. That we have to integrate it, this much. And from where to where? From this your minus pi by 2 to plus pi by 2. Minus pi by 2 to plus pi by 2. So we have to find out. So ultimately net electric field intensity will be, in place of k, 1 by 4 pi epsilon naught q by l into r, integration of cos theta is your sin theta, minus pi by 2 to plus pi by 2. So if you are calculating, you will get 1 by 4 pi epsilon naught q by l r, 1 minus 1, and that will be your 2 twice q by 4 pi epsilon naught l r is equal to q by 2 epsilon naught l square. How it comes? We know pi into r is equal to l, half of the circumference. That is your electric field intensity.